So here's what happens. Remember, when you are simplifying square roots, I'm going to show you guys the old way of doing things, and I'm going to show you a nice little trick if you forget how to do this. When you are simplifying square roots, what you are looking to be able to do, if you recall, is that you're trying to find the largest perfect square that goes into something so you can factor it out, if you will. Remember, your perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 169, 196, 225, something, I don't know, whatever.
286.
So what you're looking at doing here is you can, he's not. Is it 286? That's not 286.
Yep.
It's like 2, all right, anyway. What you're looking at being able to do here is what is the largest perfect square that goes into 24? 4. 4 times what?
6.
So you remember seeing this? Square root of 4 times square root of 6. What's the square root of 4? So my answer would be 2 root 6. Okay? Same idea as I'm looking at 90. What's the largest perfect square that goes into 90? 9. The square root of 9 and the square root of 10. What's the square root of 9? 3. So this would simplify out to be 3 root of 10. Now, a nice little trick. This works when you're just finding square roots of just a single value. Take your calculator, and what I want you to do is go to your y equals, and I want you to put in 24 divided by x squared.
It comes up as error.
Go to your table.
It says,
Okay? Now, I want you to start scrolling through the positive values of x. So if I'm looking at my positive values of x, I have 1, 24, 2, 6, 3, 2.6, whatever, 4, 1.5, 5.96, and so on and so forth. What I'm doing here is by scrolling through my values of x and y, I'm looking for the smallest positive integer that I get in the y column. If I'm scrolling through there, the smallest positive integer I get is a 6, correct? What's the number to the left of it? 2 root 6. 2 root 6. Go back to y equals. Change it to the square root of 90. Oh, not the square root of 90. I meant to type it in as 90 divided by x squared. Excuse me.
Oh, what?
If I type in 90 divided by x squared, go to my table again. Scroll through it. What is the largest value of y, the smallest positive integer value of y? What's the number to the left of it? 3 root 10.
So sweet.
It's magical. But that does. But 90 does this. You have to find the smallest value of positive value of y. It's an integer. It'll work. Works every time. Okay.
Oh.
Now the tricky part comes in when you have the division stuff. When you have fractional roots. Now the first example I have here is square root of 7 over 16. Do you remember what you do when you have fraction square roots? No. Basically what happens is
You multiply them.
you get the square root of 7 over the square root of 16. Can you simplify either one of those?
Yeah.
What's the square root of 16?
4 times 4.
So I get the square root of 7 over 4. And I'm fine because my radical is gone from the denominator. You do not want radicals in your denominator. It's bad. Okay? But now when I get to the 7
I
over
remember this. Yeah.
the square root of 7 over the square root of 2, now I got to get rid of the radical in the denominator. What we do here is, what we do is we call rationalizing. What you're doing in essence here is multiplying that square root of 7 over square root of 2 by a factor of 1. Because if you multiply something by 1, do you really change it? No. what's in the denominator? So if I multiply this by square root of 2 times square root of 2 is what?
1. 1.
2.
What's the square root of junk times square root of junk? Junk. Square root of 2 times square root of 2 is 2.
Oh. Darn it.
Really?
Christ.
Is root 2 divided by root 2 1?
Chunk
So-
divided by chunk 1? Yeah.
Now, what I'm doing here is I'm multiplying it by a factor of 1, but that factor of 1 is allowing me to get rid of the radical in the denominator. Square root of 2 times square root of 2 is 2. What's 7 times 2?
14.
And then can you simplify the square root of 14 at all?
No.
No. You're done.
Well, you
You're not
could. I mean, it could be like.
No, when I'm talking about simplifying radical, I'm talking about can I break it down, square root of 12 is 2 root
Or it's
3.
a whole number.
Things like that. Okay? I can't simplify that any further. Another idea. If you have multiplication. If I have 2 root 5 times 3 root 4, what's the order that you do this? Yeah, outside times outside, radical times radical. What's 2 times 3?
3.
What's 5 times 4?
20.
Can you simplify the square root of 20? Is there a perfect square hiding? Yeah. What is it? 4. So that's the same thing as saying 6 root 4 root 5, right? Yeah. What's the square root of 4? What's 2 times 6?
12.
And you're done. What we're doing here is we're working with roots again. It just takes a little bit of practice. But the reason why I'm making you guys remember how to simplify square roots is because now we can solve equations with radicals.
Oh.
Yeah.
Okay, so like, is it always going to be like that? Like, where 3 times 2 would be, 3 times 2 is 6, and if you already know the square root of 4, it's 2, then you can just multiply it in and then multiply it over here.
Yeah, I didn't recognize I did that. I didn't realize. I was just trying to show how the pattern works. Yes. If it does so happen where it's 3 root 4, that is 6. 3 times 2 is 6. You could have had 6 times 2 root 5, and we got total root 5 right away. I didn't even recognize I wrote that. I was just trying to think of easy numbers to multiply. Thank you. I didn't even notice I did that. When I put this example off the top of my head, what's the square root of 4? What's 3 times 2? What's 6 times 2? So I just was thinking of quick numbers off the top of my head of easy things to multiply, and I didn't even recognize that I did that. So thanks, Daisy. Oh well. Come on, let's go.
Let's go.
So here we go. Now we're going to solve.
Sure.
I am going to solve this equation by working backwards, and then at the very end, I'm going to have to take square roots. So I have 2x squared plus 1 is 17. I'm not factoring this. I'm not worried about any of that. But what I'm going to do here is what first? Subtract 1. Good. So I subtract 1. I get 2x squared is 16. Now what do I do?
Square.
No.
Divide by 2.
Divide by 2. You can't take the square root until you have just an x squared here. Now, I take the square root. Do you remember what happens if you take a square root over an equal sign? There's a rule. Very good. Anytime you take a square root over an equal sign on both sides of the equation, the rule is that you have to write plus or minus the square root of 8. And then can you simplify the square root of 8? 2 root 2, very good. So it's plus or minus 2 root 2. Remember, whenever you're solving an equation, whenever there's an equal sign, you have to remember plus or minus. If you're just simplifying like we were doing here, the square root of 12, you just keep the sign. You just keep what it is. The only time you ever worry about plus minus is if you see an equal sign. That's usually the difference where a lot of you guys will forget. Okay? From what I understand, you've done this before, but it might not have Might not remember.
Subtop is a little bit.
Yeah, I remember.
It's like you gotta group, put it.
But you guys know how to do this.
Yeah, it's the easiest thing.
My grandma can do this.
That's a nice conversation. So
1/3 times the quantity x plus 5 squared equals 7.
Leave it.
What am I going to do first? No!
Distribute.
No!
You do that.
No! Guys,
Square everything in the parentheses.
ladies and gentlemen, no. You guys are making this.
Get rid of the first.
Get rid of the 1/3.
Quit math.
Okay, enough, please. Remember, you cannot, don't break this apart. Don't do anything with it. Don't square root, don't do anything. You cannot do that until you get rid of what's in front of it.
Right.
How do you get rid of a fraction?
You multiply it actually.
Okay, so multiply both sides by 3. You have x plus 5, quantity squared is 21. Now, is there anything left on the left-hand side for me to move? No. So now can I take the square root? Yeah. I take the square root of both sides. The square root of junk squared is junk. And the square root of 21 is what? Very good. I cannot simplify the square root of 21 any further. There are no perfect squares that go into 21.
So
X equals what?
21, square root of 21 minus 5.
Careful. What I want you to get in the habit of doing here, when you subtract the 5 over, you get x equals -5 plus or minus the square root of 21. Always put your integer value in front of the plus minus. Yes, sir?
Couldn't you distribute the square to the parentheses and then go x squared plus 25?
Remember that this is, that's junk squared. That means junk times junk. It's not distributing inward. If it was, then you distribute inward. But since you've got that, it's this times this. Okay? It's a very common mistake. It's 2 different operations. All right? It's very common. All right? So when you wind up with an integer value that you got to move over, always put it in front. Always put it in front. It's the etiquette way of doing it, in front of the plus minus. Okay? It always goes in front of the plus minus. Okay? You okay?
Yeah. Yeah, Nino.
Then what's going to change when I deal with negatives? Nothing.
Lots.
I have to use imaginary numbers. Here's what happens. The square root of -1 is I. It stands for imaginary, because I love math.
So funny.
Okay?
Ah.
What happens here in working with the square roots of negative is really quite simple. All you do is you simplify your radicals the exact same way, but we're adding one step. Let me show you something. If I say what is the square root of -12? The -12 can be rewritten as the following. I can write it as the square root of -1 times the square root of 4 times the square root of 3. Do you agree? I'm just breaking it apart.
Yeah.
Square root of 4 is what?
2.
Square root of -1 is what? So I write this out as 2i root 3. Integer, imaginary, radical, in that order. So the square root of square root of 12, we all know, is 2 root 3. The square root of -12 is 2i root 3.
So you just add the.
That's it. Yeah. Same idea. If it's the square root of -18, well, square root of 18 is, well, 9 and 2, so it'd be 3 root 2. So the square root of -18 would be 3I root 2. What I'm introducing you guys to today is what's called complex number. It's numbers you can think about, you can't really see them, but they're there. And what it allows you to be able to do then are these. In the past, when you guys got to x squared equals -9, you would say no solution, you can't do it. We would say no real numbers, right? Remember that? Well, that's right, no real numbers is true. It's an imaginary number. How do you set up x squared minus equals -9? Do I have to move anything on the x squared side? So if I just have to take the square root, what's the rule whenever I take a square root over an equal sign? Plus or minus. So x is going to equal plus or minus, well, what's the square root of 9? And what do I have to put next to it? So when I'm working with the square root of -9, it's still plus, it says I'm taking it over an equal sign, it's still plus or minus 3i. Okay? In the next one, I have 2x squared plus 3 is negative 13. Subtract the 3, so you get 2x squared is -16. Divide out the 2, you get x squared is -8. And what's the square root of -8?
2 root 2 imaginary?
2 root 2 imaginary. Okay, you're right. So remember, it's x equals plus or minus 2I root 2. Always bring the I out in front of the radical. So we're setting up and solving these just like you did before, but just have an imaginary to work with. Okay?
I like how you write your eyes, Mr.
Thank you. And the next one, I have the quantity x minus 1 squared equals -7.
So are you supposed to write the eyes like?
Yeah, I've always put a tail on an I. I put a tail on an I, I put a tail on a T. I don't know, it's just how I always did.
They're dogs.
So it's x minus 1 equals plus or minus square root of -7.
-1.
One I. Plus or minus 1.
Hold on. We agree that you got to move the 1. So it's x equals 1 plus or minus the square root of -7.
Oh, 1. Sorry.
What's the square root of -7? I root 7. So now it becomes 1 plus or minus I root 7. You always go with the integer value plus or minus imaginary radical. When you're taking the square root of -7, it becomes I root 7. That's for the radical portion. The 1 is all the way out in front of it.
Why did it go from -7 to -7?
Because the square root of -7, remember, I can break that down. The square root of -7 can be rewritten as the square root of -1 times the square root of 7. The square root of -1 is I, and I can't simplify the root 7 any further. Just like I did with the square root of -9, it became 3I. Because the 9 you can take the root of, whereas the other one you couldn't. The square root of -12 was 2I root 3. We keep the I out and just simplify the radical. Simplify the radical like the rest of the way you would.
Darn angry bird.
All right, try this one.
You can do it.
What'd you guys do first?
Squared it.
Oh!
Subtracted it. I don't know why I said that. I'm sorry. Yep.
Then,
Squared it.
we're not squaring anything until we move everything over. It becomes negative 49.
Right.
Now I take the square root. What happens if you didn't take the square root over to the equal sign? So I have x plus 5 is plus or minus, what's the square root of negative 49? 7i.
Oh, 7i.
Now I subtract the 5, and I get x equals negative 5 plus or minus 7i. Yes!
That was very successful for me, Mr.
Good. Remember, you're treating these things just like you did in the past, as far as how they're set up. The only thing different is you have to worry about moving that I around. You simplify radicals like you would every other day. If you're not sure how to simplify the radical, could you use that trick of taking the number over x squared in your table? Yeah, just remember to put I in your answer if it's negative, that's all. That's all I gotta remember. Okay.
Ooh.
There's 10 problems of equations. The other ones are simplified. Jeez Louise.
Well, Mr. Murphy, you make it look so long.
What happens?
It's like Arabic or something.
These first handful are simplifying. Are taking square root of 12, taking the square root of 18. Some of them working with multiplying by conjugates, things like that. Things are in the denominator. The next 5, or excuse me, the next 11, pardon me, are solving equations. Okay? Of equations. Those last, the 5-3 are all regular answers. The 5-4 are the ones with imaginary numbers. You do the same work, you just might have an imaginary number. Giving you guys a little bit of time to work on this now. Tomorrow we will go a step further and do properties with imaginary numbers. How do you add them? How do you subtract them? How do you multiply them? And how do you divide them? That's what we work on tomorrow. Thursday we're going to quiz 5-1 through 5-4 and go from there. Locally, locally.
Clickety bye.
Yeah.